Today you're beginning your road to graphing polynomial functions. And basically, we just need to be able to identify it today. So I'm going to give you a few notes on here, and then we'll do a couple problems in class together before I set you free. You guys know what a first degree polynomial looks like. What do I mean by degree, by the way? The greatest exponent is 1. So what does a polynomial with degree 1, what does it look like? Something x. You guys know this. What if I made it look like, I don't want to leave it on this paper. What is the degree of this polynomial? 1, right? What is that graph to? What does it look like?
3.
Sorry?
3 over 1.
Okay, but what is it? All I want to know is what is it?
A line.
It's a line, right? It makes a line. So polynomial of degree 1 makes a line. Polynomial of degree 2. F of x equals, things can happen there. We can multiply, add, subtract. But what does a polynomial of x squared, degree 2, look like? Parabola. Now you guys are with me. Good. And that's about as far as we've gone in our polynomial careers. Today we add a little bit more. Degree 3 looks something like this. And it does not need to match mine exactly. The arms need to be going in the same direction, and there does need to be a turn for those arms to be going in the same direction. All right, degree 4. Something like that. Degree 5. Oh, it's getting really crazy now. I want you to notice that there are, we'll talk about this in a minute. We'll wait a second.
Do those lines, like on 3, 4, do they go up forever?
Yes.
So
Yes.
only those numbers go up.
Mm-hmm. And degree 6. Wowza. So let's see if we can use some deductive reasoning and come up with some common things about these guys. What do you notice about all of the even degree functions?
They end up just going up.
The arms are going in the same direction, right? Okay, so I can put that here. The arms are in the same direction. So what do you notice about the odd degree? Opposite direction, one up, one down, however you want to say that, right? I'm going to put one up, one down, just to be different. One up, one down. Okay. How many turns does degree 1 have? 0 turns. How many turns does degree 2 have? How many turns does degree 3 have? How many turns does degree 4 have?
3.
You guys noticing a pattern yet? All right, so without finishing this off, if I have x to the 6th, how many turns could there be? X to the 12th. If I had an x to the 12th.
11.
11. It's always one less. Now, there could be imaginary terms, and so you might not see them graphed, but we'll talk more about that later. Okay. Something that is very, very important to know is what direction our arms go based on if our leading coefficient is positive or negative. So you guys know that this is a positive slope. Do you agree? That's a positive slope. This is a negative slope?
Yes.
All right. Parabola, because we're good at parabolas. Is that one positive or negative? Positive. And this one is negative. So we're going to apply what we know to the new stuff. What arm is in the air for a positive one when it's degree 1 here? Right is up, left is down, right? So I want you to look here. Is this a positive or a negative function, this guy right here?
Positive.
Because what arm is in the air? Right. If you needed to, you could, and I don't want you to really do this on your journal, but you could connect the ends and you could see that you have a positive slope, right? So what would a negative slope look like? A negative,
It would be
what arm would be in the air?
left.
All right, so if, whoops, I thought it was a negative. Here's negative, right? That would be a negative. Or who cares how many turns are in there? But both arms would be going down. Positive, and positive. Because my OCD is at work, I'm going to say 4 turns, 5 turns. And then this multiplicity thing is new for us. We've seen polynomials written like this. We've got x minus 1 twice. Rather than write it twice, we put a square. Yes? Right here, this guy means multiplicity of 2. That 0 shows up twice. And it does something kind of fun to our graph. If we have an even multiplicity, turns at that 0. I'm going to put turns around at that 0. Odd multiplicity, this guy has an exponent of 1, right? And this guy has an exponent of 1, so they have an odd multiplicity. Sometimes we don't think to see it because it's not written there. So odd multiplicity passes through the 0. Now we're going to kind of sketch this. We're not going to talk about maxes and mins in an exact fashion because we needed a little calculus for that. We're not there yet, right? So we're going to get a rough sketch of this. We're going to call it good enough because Alex will have the graph for you and you need to identify it. So the first thing I'm going to do is I look at this, and this is from last week. That was a long time ago, I know. It is in factor form, so I can look and I can find out what my zeros are. What are my zeros? What makes this one 0?
0.
0. What makes this one 0? 1. And what makes this one 0?
-2.
All right, so we're going to plot our zeros. Got 0, 1, and -2.
Spread out.
What's that?
Which is more spread out.
Yeah, that would be easier to graph for sure, wouldn't it? Now, the next thing I want to look at is I want to figure out which way my arms go. Do they both go up? Do they both go down? Is the right one in the air? Is the left one in the air? So I've got to look and I've got to figure out what degree is this. Now, some of you are going to want to FOIL that out to figure out that degree. You don't have to do that. Save yourself some time and kind of just use some reasoning here. Is this one going to give you an x squared? Yeah. Times another x, which would be x cubed, right? X squared times x, x cubed, and then do I have another x? So am I going to end up with something, 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 but an x to the fourth? Absolutely. So I know that this has a degree of 4, right? So I need to think about that, and you guys are going to get better at this. Right now you're going to be looking to your reference sheet repeatedly, and that's okay. But degree of 4, that's an even. So what do the arms do? They're going in the same direction, right? And are they up or are they down? Why are they up?
Because it's a positive.
This guy is positive, so both arms are up. All right, so I know both arms are up. All right. And then I need to look and I need to see, where does it touch a 0? Where does it turn around at a 0? And where does it pass through? So let's see. At this -2, does it cross through or does it turn around? All right, so it has an odd, right? So it passes through. All right, passes through. Cross there. All right, at the 0, that had a degree of 1. Odd multiplicity means we're going to pass through there too. And at my next 0 of 1, it had a multiplicity of 2. Even multiplicity means it turns around at that 0, and that's what this does. It's going to go like this. It's going to hit it and bounce back up. Now that shouldn't be a point there. That should be a nice round something or other. And I've got a sketch of what that polynomial looks like. That's not a for sure graph. Let's practice some more. Keep that reference page in front of you. Maybe we'll just start here. That's a good spot to start. Okay, so they're going to start off kind of nice here. What does it mean by fall to the left? Fall to the left would look like this. Rises to the right. So that would be this one. Does that make sense? Falls to the left, rises to the right. How about falls to the left and falls to the right? What would that look like? Something like that, right? Okay. So now that I know what those mean, I kind of like to start here. I don't want to read that yet. It's negative and it's even. Because it's even, which way do the arms go? Same direction. But because it's negative, which way do they go? They both go down. Which one of these say they both fall? All right. This guy is odd. So what do you know about the arms? Opposite directions. But it's positive, so what arm is in the air? So it looks something, who cares, like this. All right. What's it doing on the left? Falls. And what does it do on the right? Is that okay? Yes, ma'am.
Why don't you just use like the first number? Right now I'm going to like 7x.
So the degree tells me about the arms, and the leading coefficient, positive or negative, tells me which direction they face. You could use the other numbers to plot points on your graph and connect the dots. But this helps me identify what it looks like without plotting any points. And sometimes that's really nice. Saves us a lot of work. Good question. All right, let's go to graph identifying, wherever that be. Okay. I have up here, should we do the factored form first since that's friendlier? I think we will. We're going to go with the bottom one. First thing I want you to tell me is what is its degree?
4.
X to the third times x, I've got a 4th degree. That's even. And my leading coefficient is positive. Tell me about the arms. Yeah, both of them are going up, right? So automatically, you guys, I can look at this and I can get rid of A, B, E, and F. So I have narrowed it down to, I can't write on it because it's going to move here in a second, C and D, right? Let me write this so I can see it. 2x minus 1 cubed, x plus 2. All right, so I'm in between this guy and this guy. Let's erase this. Now I look at this and I've got to look at my zeros. Where are my zeros? They are at 1 and -2. Odd multiplicity of 3 here. So does it turn around at the 0 or does it cross through?
Cross.
And how about this one? Turn around or cross through? They both cross through because they have odd exponents. So I look at these. Do those zeros cross through? Here and here, or do they turn around? They turn around. So I come down and look at this. It crosses through, and it crosses through. So that graph goes with D. Is this crazy? A little bit. Seeing some overwhelmed faces. What do I have to do to this function, g of x, before I can figure its zeros out? We need to factor it, right? Does it have a greatest common factor? What is it? I'm going to pull out negative x. Is that all right? I would be left with x squared plus 6x plus 8. Continue factoring. Are there two numbers that multiply to be 8 that add to be 6? 4 and 2. So I have all of my zeros. I've got 0, -4, and -2. All of their exponents are 1, meaning odd. So with all of those zeros, does it touch and turn around, or is it going to cross through? It's going to cross through. We're for sure going to cross through. So they all cross. What's my degree? 3. All right, so arms go in opposite direction, yes?
Wait, so how do you know when you add the exponent, or when you add, when you add them in the
I can only tell what degree it is when it's not factored. My degree is after it's all been multiplied. Does that answer your question? This one I had to multiply together to come up with the degree. This one is already multiplied out, so I could come up with the degree, but I had to factor it to get the zeros. So they both have their advantages. Let's see, where were we? Oh, odd degree, arms go in opposite direction, but it is odd. I mean, not odd, we already talked about that. Odd, opposite direction, it's negative. What arm is in the air?
Left.
All right, so I know it looks something like this, yes? Okay, let's find these. Wow, I should have not used blue. Okay, I know it could be A. Would you guys agree?
Yeah.
Or it could be F. What happens at this 0 on F? Does it cross through like we predicted? No. So is that it? No. It is for sure. We gotta get rid of blue. That one right there. So do you see how we have to use all of these steps to identify the graph? Would you like to do one more together, or do you want to get in there and work with each other? I mean, some of you are going like this. If you're ready to work, go ahead and open it. It should be ready to go. I'll do one more with the class.
Can I go to my phone with charger?
You may. All right. My zeros for that guy are 1 and -2. 1 has a multiplicity of 2. So I know at this 0, it's going to touch and turn around. This one, it's going to cross. Now when I draw it that way, depending on which my graph is, it could be that way, couldn't it? That just reminds me that it's going to turn around, not necessarily its direction. All right. And then Grace's question, why do I have to multiply that one out? Because it's in factored form. I want to know its degree. So there's an x squared times another x. I've got an x cubed. And my leading coefficient is positive. So I know left will be down, right will be up. So that puts us between B and E. What happens on E on both of my zeros? They both cross. What did I predict? That one of them was going to turn around. So it has to be B. That one turns around. That was left over from the last one. It turns around right there, right where I predicted it. I'll give you a little more confidence, enough that you can ask questions when you're stuck.